Bismillahirrahmanirrahim. Today I come up with the proof of the distance formula. So first of all, we will take a Cartesian plane here. Let's consider this as the Cartesian plane. In the Cartesian plane, we are having 2 points. Let's consider these 2 points here. Let's consider one point as P, having coordinates x1, y1, and Q, having coordinates x2 and y2. Once we will join these 2 points, we'll get a line segment PQ, and then from point P draw perpendicular, and from point Q draw perpendicular to x-axis. So dear students, it is x-axis here. This is the origin. This is y and y-axis here. So first of all, we have taken here a Cartesian plane x and y-axis, x-axis and y-axis. Then on this plane we have taken 2 different points, one as P and second is Q, having different coordinates. P is having coordinate x1, y1, while as Q is having coordinate x2, y2. Then from point P I draw perpendicular to x-axis, and from Q I draw the perpendicular to x-axis. Then from point P draw one more perpendicular to Q, and let's call it as N here, M and N here, and let us denote this as PL. Draw one more perpendicular from point P to QN line and denote that very perpendicular with L, PL. So in this manner we are having a figure, and the figure is now the triangle. Let's have OM. OM is having value x1 because it is the abscissa, and then from M to N we are having distance, and that distance is from O to M is x1, and from O to N is x2. O to N is x2, and it means from M to N we are having x2 minus x1. So OM is x1, MN is x2 minus x1 because ON is x2. It is x2. And similarly, in this side, if we want to calculate MP, it is y1. It is the ordinate. And from N to Q, we are having y2. It means LQ is y2 minus y1 because this is y1 now. So it means QL is y2 minus y1. Rather, I will write these points here. Here in figure, OM is x1, ON is equal to x2, MN is equal to x2 minus x1. x2 minus x1. Similarly, we will take the ordinates. MP is equal to y1. Then we can say the NQ is equal to y2, but LQ is equal to y2 minus y1. Dear viewers, as we are having here triangle, right angle triangle, now we will take now in right angle triangle PLQ, we will use Pythagoras here. Pythagoras says hypotenuse square, that is PQ here, is equal to PL square, that is base here, plus LQ square. We will assign them the values. Values are PQ square this is the distance between 2 points that we had to calculate. PL means MN. MN and PL, they are equal, so we can write here x2 minus x1 square. So it means MN and PL, they are of equal length. So if it is x2 minus x1 here, it is x2 minus x1 also here. So that is why I write here, instead of PL, I write x2 minus x1 plus LQ. LQ that I have already calculated, that is equal to y2 minus y1 square. So what is PQ? PQ is the distance between these 2 points. One point is P and second is Q, and we have to find the distance of these 2 points. So we will take root on both sides. Taking root on both sides. Once we will take root, we will get PQ square on this side is equal to under root of x2 minus x1 square plus y2 minus y1 square. Square and root cancel out, so what we get, we will get PQ only is equal to x2 minus x1 square plus y2 minus y1 square. And dear students, this is known as the distance formula. So distance formula is as, first of all, we will consider 2 points on the Cartesian plane. One is P and second is Q with the coordinates x1 and y1 and x2 and y2 respectively. Then we will calculate the abscissa and the ordinates. Then we get a right angle triangle after drawing the perpendiculars to the x-axis and one to the QN side. And then we will use Pythagoras formula to the right angle triangle, and what we will get hypotenuse square is equal to the base square plus perpendicular square. Then we will assign the values. Once we will assign the values, we will get the required formula that is known as distance formula. Hope you understand it very well. Thank you.